The Brisbaner, the world's largest timber building. The Brisbaner, located in the CBD in Brisbane, will be the tallest timber building in the world. With an innovative shape and design, it will have a height of 135 meters, made up of 30 stories, 26 of which are offices, and the 4 bottom stories for commercial use. This emblematic structure is expected to attract a large range of companies as an ideal office location, as well as high-quality restaurants and stores to enhance the offerings of Brisbane City. The building will form part of the Brisbane Waterfront Master Plan, which will create healthy environments and activities for both locals and visitors, as well be a part of the Brisbane identity as a futuristic city. The beams and columns in the trusses and floors will be made of glulam. The advantage of glulam is that it can be manufactured with large cross-sections and lengths. Large factories are required in the production process of glulam and can present itself as a challenge during construction. The staircases and elevators will be made from CLT, which is ideal for walls because it has grains in 2 perpendicular directions, allowing an increased strength in shear. Drywalls will be used to cover inside walls and elements to reduce flammability and absorb water. The structure is designed with 4 bases, shown with the 4 small squares in the left figure. They meet at the 4th story and become one rectangular structure, shown with a big square in the middle of the left figure. The right figure shows how floor 5 to 30 will be designed with elevators in 2 corners and stairs in the other 2 corners. The stairs will be the escape routes of the building. The 9 columns in the middle will provide a support to beams in the floor. Each beam will have a span of 7.5 meters. Gravitation load on each floor are transferred from the beams through the 9 columns in each floor and the truss system into the facade. These columns transfer the loads into the base section of the building. Some of the loads are transferred into the ground, and some are transferred into 4 arches through a truss system that evenly distributes the loading along the 4 arches. These arches are 20 meters wide, which creates a large entrance into the building from all 4 sides. A bracing system and the 4 CLT cores takes the lateral wind loads. It transfers the loads into the columns and is then transferred to the base through the same structural system as the gravitation loads. The bracing will cover 3 stories and will be identical for every 3rd story. Simplified structure was modeled in space gas. Each column will have to resist approximately 7,500 kilonewtons of compression. 750 times 750 millimeters GL18 column is needed to take the compression forces. This is with a compression resistance of 45 megapascals and a K1 value of 0.8. The beams will have to resist a maximum bending moment of 450 kilonewton meters and a maximum shear force of 650 kilonewtons. A 450 times 650 mm GL18 beam is needed to resist the bending and associated shear forces. Currently, the world's tallest timber structure is Mjøstårnet in Norway. It is an 18-story commercial and residential building where the main structural system is made of engineered timber such as glulam trusses and CLT walls. It has 4 corner columns with dimensions 1485 times 625 millimeters, which is bigger dimensions than in the Brisbaner, which means that it is possible to build the columns in the Brisbaner. Through the CLT and glulam materials used, it is expected that the main bearing system will withstand 120 minutes of fire and the main timber columns must be designed and tested for self-extinguishment. The facade, internal walls and exit routes will be designed with exposed timber that will be covered by fire-retardant paint. Fire stops will be designed for the facade and a compartmentation system that will lock the fire in every floor. The entire building will be fitted out with sprinklers, a fire detection system, alarms, fire extinguishers and fire hoses. A smoke management system will stop smoke passing from one fire compartment to another. In this stage of the design, the overall structural design and calculations show the dimensions of the most critical components. Further research is needed to be done into the arch structure and the base of the building regarding how loads are transferred into the ground.